with WRP. We've been working together for a couple of years now. So it all
Great, thank you. Does everyone mind if I cut the lights? We show some tiny things on the screen, but I'll try not to let everyone fall asleep. And to control the slides, I just use the time. So, my name is Isaac Baker from Harvard Humanitarian Initiative, the Signal Program. I'm Imagery Analysis Manager, which been serving that capacity for about almost 8-9 years now. So we actually started originally back in 2010 as a Satellite Sentinel project. I don't know if anyone's familiar with this initiative or collaboration, but we were actually originally set up in 2010 to monitor the buildup and escalation of violence and the resulting effects of that violence in Sudan, what was soon to be South Sudan, when South Sudan was voting for its independence. The collaboration was these people. So it's us at Harvard Humanitarian Initiative. We did largely the analysis and the research behind the project. We had the Enough Project who did the advocacy. Us at Harvard cannot do advocacy at all, so that was the Enough Project's domain. We had Not On Our Watch, which was the money by George Clooney. And then we had Digital Globe, who provided us the imagery, and they started out doing the analytic capacity of it, but then that eventually got handed over to us. And then we had Google, who put their name on everything. I'm going to start out with one of the first images that we ever analyzed during SSP. So this was when we were monitoring the area of the Abyei region. So I don't know if anyone's familiar with the contested border line of Sudan and South Sudan, but the Abyei region was one of the key focal points of where we're starting to look, just because we're starting to receive reports of an escalated attack that was moving down through the northwest corridor, northeast corridor, down into Abyei town from South Kordofan state, Sunni armed forces. And we're receiving reports of villages being burned. Now, at this point, when we started doing analysis in this area, it was during a very dry period. So it wasn't during the rainy season. A lot of vegetation was desiccating. So I know we talked a lot about multispectral and near infrared the past couple of days. So you can kind of see it in this image. This is actually how we received the image at the time from Digital Globe. And you see the red trees in the shot. But by and large, during this time, we're also seeing villages throughout South Kordofan state that suffered from incidental burn or accidental burn. And that can be from a number of things, a fire that gets out of control, or even someone can drop a cigarette and can light up a lot of desiccated vegetation, and it can cause some serious damage. But we were receiving at that time reports of intentional destruction in these villages. And so what we're looking at here is Baker Abbey, which is just probably about 25 kilometers outside of Abyei town. Now, you see these dark rings here throughout the shot. These are tuples. Is everyone familiar with what a tuple is? Central Eastern Africa, largely informal dwellings and formal dwellings, but they're wattle and daub huts, walls with thatched roofs on top. And the reports that we were receiving is that the method of attack in this area was just walking up to the tuples and dropping some kind of flame torch matches on top of the thatched roofs, and thus destroying the tuple from the burning thatch falling down. So when we received the reports of the intentional attacks, while we're also observing the incidental fires that were burning a good number of villages at that time, we saw this image. But at this point, we're able to determine that this was an intentional act, not an incidental one. Now, can people take a look at this image and kind of guess why we came to that conclusion?
But it only spread through the structures.
Yes, exactly. So there's no scorched earth between these dark rings. Now there's also another key thing in this image which some people experience in the military may pick this out, but in this image, we're able to identify that the people in this village, which was largely occupied by SPLA-aligned people, Sudanese People's Liberation Army, that they were expecting the attack to actually come from the northwest, as opposed to the northeast, from what we heard. So can anyone see in this image why we came to that conclusion also?
Is Levash on the northwest?
So in the northwest, so this is aligned, north, south, east, west. So in the top left-hand corner, does everyone see that? Yeah, yeah. So this dotted line right here, we're called fighting positions, or foxholes. And so the people in the village, dug these holes as a protective perimeter outside the village. So they were expecting the force to come from the northwest, which it did, but it was not enough to protect Major Abior. And I like to show this image because even though it was one of the earliest ones that we looked at, it was something that we gained a lot from. To kind of put in perspective, at that time, the imagery that we were receiving, by and large, was probably about 2,000 square kilometer swaths of digital globe imagery. To kind of dial it back a little bit, my background originally wasn't in imagery analysis, it was actually as an investigator. So I used to work for a small NGO called Physicians for Human Rights, where my background was investigating torture cases, mostly committed by the CIA at the time. But when I came on to the Satellite Sentinel project, it was because my then director became the director of this program, brought me on as for research capacity. And through that, I was fortunate enough to work with the Analysis Center at Digital Globe, who was fronted by, and still is actually, he left for a little bit, but returned Stephen Wood, who was the head of the CIA's imagery analysis capacity for about 15 years before he left the government to join Digital Globe. But his team were veterans in conflict analysis. So there were people from all different branches of the military in different countries as well. So we had Africa experts and we had Southeast Asian experts that worked in the analysis center, but they weren't humanitarian focused, right? So their analysis wasn't through a humanitarian lens, where in our research capacity we were. But I was in the fortunate position to learn a lot from them and their imagery analysis. And so this is all very high resolution imagery that was being analyzed. And traditionally that's, I'll go into some slides on that later, but that's how military conducted imagery analysis for decades, was photographic manual analysis. And so everything that we did was, and largely still is, manual. It would be 15-hour workdays of us scanning through very high resolution imagery. Usually doing a temporal change detection where we'd have two images synced up in our software. Largely we use Erdos Imagine. I don't know if anyone's familiar with that remote sensing software, but it handles large TIFF files very, very smoothly, very well. And so we would link up two images of the same area from two different dates, side by side, and then we would scan it and look for change. And largely what we're looking for is human behavior and human patterns. So we wanted to look for movements of military, we wanted to look for military buildup, we wanted to see the establishment of forward operating bases and temporary operating bases of areas of interest that we were key on analyzing. Sorry. So now you can see here, from the imagery that we collected, and this is over, so this is actually not Major Abior, but this is in the same region, contested region of Abior. And this is a village called Dungop. And Dungop is actually where we first started to notice the pattern of destruction that was leading into Abyei town during what was eventually the large invasion of Abyei in May of 2011. And here we were, in a very rare scenario, able to get before, during, and after shot of burning tuples. And so here you can see fine here. And then in this shot, it's actually, this is also a Worldview 2 image, but it's very hazy. There was a lot of smoke. So we had to adjust the contrast to kind of, so you can see the flames better through here. And then you can see a good close-up of what the effects of the burn tuple are. And I'm bringing this up for a reason, and you'll see in the next slide, where we kind of, I'll show you in a second, but you see here, the dark circle around, that's the Wadham Daub walls, but you see the white ashen burned material in the middle. And this is something that we noticed a lot as we're looking through Sudan, and what was soon to be South Sudan, so largely on the border. I know a lot of you are familiar with places like Gida in South Sudan, Banton, Bentiu, but also in Sudan, so Abyei region, Difra, Ejlich, and we just noticed this a lot, the burn tuples. And one thing that we also notice is that they are very consistent in their construction and size. I mean, they do vary in size among themselves, but largely you'll see 7-meter in diameter tuples throughout the area. But then you see also some smaller ones that, around 4 meters in diameter. But this was our first foray into actually developing an algorithm, because as we're looking through all this imagery, thousands of square kilometers of high-resolution imagery, which takes up a considerable amount of time, we were finding a lot of places that weren't mapped at all. And you got to keep in mind, back in 2011, 2012, it wasn't as thoroughly mapped as it is now, even photographically. So I mean, if you look on Google Earth now, there's tons of archival imagery over these areas that you can go through. But we had so little to work with. We had paper maps, honestly, at the time. So we would blow up at the printers giant paper maps on cardboard stock, maps that someone like Matthew has made in his past at Reach, UNOCHA maps, things like that, and we would put them on the wall. We would actually just have pins with thread attached to them, dry erase markers, and that was largely our major technical capacity at the time. But we're noticing all these areas with tuples that weren't mapped as scanning through the imagery. And so at that time, we contacted a friend of a friend, actually a colleague of mine who kind of served as our data intel lead. She was in charge of gathering ground information, which was primarily the fuel to the imagery analysis. Without the ground context, without the information from the ground, this kind of be lost endeavor. And her name is Brittany Card, but a friend of hers, Mike Hughes, who was a professor, or now professor, at Brown University in computer science, and he's a postdoctoral fellow at Harvard as well, was able to help us out in developing an algorithm that detected tuples. And so you can actually see in this shot here that tuples, they're not just circular as well. We've noticed that a lot of them are pyramidal roofs in shape with square walls. But what he did, apparently, and if you ask me questions about tuple detector, the actual nut and bolts behind it, I'm a little ignorant on because I don't have a background in machine learning. But what I did find is that it worked. It worked for us initially, or largely it worked for us. But apparently what he did was repurpose an algorithm that was used to detect craters on the moon's surface. And then in that effect, the circular shapes, we're able to factor in the parameters that we're observing so often. And so, with the high resolution satellite imagery, we're able to implement a lot of data into the machine that we kept seeing reoccurring. So the circle here on the circular tuple is identifying the pitch. And so we see the shadow of the pitch of the conical Tupel roof. But we kept noticing that over and over again. I mean, at this point, we probably saw, 60, 70,000 tupels. So you start to kind of get used to how they look after a while. The pyramidal ones, you see here, have, a very significant triangle shadow on the side that's obscured from the sun. And, like I said before, very consistent in their size. So, these two were identical in 7-meter diameter. And so factoring all that in, the first run that we took with the software that he developed for us had a 90% success rate. And, of course, false positives were factored into it. So trees, rocks, wells. Wells actually almost look identical to a burned tupel. And especially a burned or destroyed tupel that it wasn't a recent destruction. It's something that vegetation can grow over time, and so that would leave more of an indentation in a ring, which can often be confused visually if you're looking at it. And myself, as an analyst, something that would look like a well or even a corral for livestock. But I'm going to dial it back a little bit here and talk about where this type of imagery all began. So it was developed, what we know now is very high resolution imagery. It was largely built for espionage. The US government back in 1959 developed what was called the Corona program. This isn't actually a Corona satellite, this is the Hexagon, which was kind of a later model. But I want to go into it briefly, not to just show you like how things have changed so much, but more how things are the same still. Right? How what they were looking for back then was very similar to what we were looking for, and how we were analyzing and how we were observing things, and also just to show you the value that it was at that time to collect information photographically that you can interpret from a remote location. It's at that time, and still it's something significant. And now we have so many different types of sensors that detect things on a level that's basically to the untrained eye almost uninterpretable. But here we have the Corona system, or the Hexagon system, but there's a picture of the Hexagon system. But Corona started in 1959, and they were kind of rudimentary, as Jamin showed yesterday, very crudely designed kind of buckets of tin that they would shoot up into space with a rocket. And these were loaded with the capacity of magnetic film. And so it was tens of thousands of feet eventually of magnetic film that was loaded into the Corona system. And once they had their ground control and their computers set to capture imagery, they would photograph largely Soviet, Russian forces and installments and air bases and things like that. And then once that satellite film roll was full, like a old-fashioned camera, then the retrieval process occurs. And this is where when I first learned about this, it blew my mind just to see the effort involved in doing this. So once that canister was full, it would eject out of the satellite, and then they would have to coordinate a retrieval process of where they would send up an airplane with 2 giant hooks attached to the back of the airplane. And then the canister that was ejected has a parachute that would pop out once it reaches a certain altitude, and then they would have to time it perfectly for this airplane to snag the parachute. And then they would, most of the time, get the canister. A lot of times they missed, and a lot of times they would have very valuable information land in some remote farm in Venezuela with, top secret written on the side of the canister. It wasn't the most ideal situation, but once they get that canister, they develop it, if you would regular roll of film and then put it on a light table. And here we have a picture of an analyst looking at a light table who looks pretty like me. And they would observe photographic imagery. And here you can see this is actually a declassified shot from 1966 over Leningrad. You have a thumbprint here of the animation itself, this is something that we picked up. So if you are actually interested in looking at declassified old imagery from the CIA, U.S. Geological Survey hosts a large amount of corona and hexagon imagery from late 50s, I believe, up until probably late 70s. But the thing is that when we're looking at their old imagery, we started to notice that not only were we looking for similar capacity and similar functions, but we're looking for the exact same thing. Because in Sudan, what was being used in Sudan were old Cold War machinery. So they had old Antonovs, old Mi-16 helicopters, Tupolev, Sukhois. I mean, we're seeing all these in Sudan, but they were also what was being used in the Soviet Union at the time. And so, that gave us a good, kind of a good foundation of, how to observe how these things have been traditionally used and implemented, and then seeing how it was used in Sudan. And that's going to lead into this shot here. So this is the Cauda Valley. This is actually one of the last things that we worked on during the Satellite 7 project. But this is an important image to show because it shows how the ground context is important. How to know your area and how to know how things are being used, what the methods are. This is kind of what guided our analysis, is all the ground context that we gathered. And this last report was going to be intended. So one thing I did mention earlier is that every report that we put together, that we published, it was published. It was open to the public. But the majority of the things that we analyzed and that we found, we never published for a number of reasons, largely security reasons. But in this one, this report was intended to be delivered to the White House at the time, under the Obama administration, it was 2012. And basically he wanted to see what one of these, imagery briefs that we're putting together, these reports that we're putting together, what kind of information had at the time. So at that point, the U.S. government was largely, I don't want to say not interested, but we hadn't seen interest from the stuff they were analyzing. But it was a different story for, say like the UK government, the House of Lords were actually using some of the reports as evidence to try to intervene in activities that were happening in the Blue Nile state once we started observing that area in 2012, but still not much happened there. Anyways, so we're scanning through, working through the entire weekend and looking through Cauda Valley, trying to find evidence of the massive amount of reports that we're hearing from the ground on indiscriminate bombardment and harassment bombardment. Is anyone familiar with these terms? So basically, it was a term that was given to a method of action that the Sudanese armed forces were taking at the time with the Antonovs, the Antonov AN-26, which is a transport plane. It's not a bomber or a fighter plane or anything like that. And what they would do is they would fly over people's orchards and their farms and their villages, not with the intent of killing per se, but of destroying the crops, but also in effect harassing and terrifying the populace. And so we're trying to find evidence because we had so much imagery of Cauda covering the time span of when this activity was occurring. And we're looking, and I remember we're probably about 4 days straight, staying up 17 hours, scanning, and then finally we come to this here. again, I know it's kind of small, but we came across these two gray plumes. I'll blow it up. These two gray plumes are hanging over this. Is anyone kind of familiar with this tree formation? The orchard? Yeah. Citrus orchard. So these two gray plumes were hanging over there, and you know, we've seen our fair share of smoke throughout this area, but this looked highly suspicious to us. And, you know, at that time, in our coalition, we had to get everything verified. You know, not just through the higher-ups at Harvard that had to sign off on all our reports, but the Analysis Center at Digital Globe, even though we were largely doing the analysis at that time, we had to run all our findings by them for approval. And so I sent this to the Analysis Center and said, you know, I think you have something here, something that we can work with. It looks like a bombardment of some kind. And their response immediately was, well, we don't think so. It looks like an incidental burn or agricultural fire. Something like slash and burn, which is not even close. And this was because they didn't develop that intimate knowledge of the area, because we were looking at this forever at this point. I mean, for 2 years to this point, 15 hours a day, looking through all of South Kordofan State and the Nuba Mountains, developing a database, not just of ground context, but of what we're seeing visually in the high resolution imagery. And so, you know, I said, we've seen our fair share of agricultural fire in the area. So here you have slash and burn agriculture and burning the vegetation to create soil for planting, and also incidental fires. And so this is actually in the Cowden Valley itself at the same time, but this wasn't from bombardment. This was, you know, incidental fire. And if you actually go on Google Earth now, they have robust imagery archive on Google Earth. If you go through places like Cowden Valley, or even throughout the CAR, or DRC, Ethiopia, Somalia, you're going to come across incidental burning because it happens so often. And you're going to see it in the imagery. I guarantee you, if you go on there now and you just take a good look for about 10 minutes, you're going to see fire. So we came back to the Analysis Center with that argument. And they said, fair enough, because we've also seen our fair share of bombardment. And so this was also in the Cowden Valley. This was about 2 months earlier. But here you can see this looks a lot more like what we observed than this. The gray plumes just hanging there. It wasn't streaming white smoke coming from the vegetation. It was just gray clouds hanging over the surface. And so they said, you know what, you're right. It's a bombardment. But they thought it was actually ground artillery, a mortar, something like that. But just from the experience that we've seen with aerial bombardments, you know, of course, they had more background in actual use of this weaponry. We didn't. But just from what we've observed so much, you know, we thought this was an aerial bombardment. And we started scanning and came across the second set of plumes. The second set of plumes here, also, right above orchards. With the database that we built up at the time, we're able to identify that these orchards were located right outside the village of Engardo. These were actually you know, food that was used for the people in Engardo village in the Cowden Valley in South Kordofan State. And then we had to figure out, okay, we have all this imagery, so this is just a small section. This is probably about 25, 30 square kilometers of imagery. And this is just a chip from an image that's probably about 1,800 to 2,000 square kilometers. So we still had a lot of looking to do. There's still a lot of something in there. These look pretty recent, right? They're hanging pretty low over the ground. There's a possibility that whatever caused these, if it isn't bombardment, could still be in the image. But we had to guide our analysis. We had to guide our scanning. We were able to build up a database at that time of all the airstrips that were in the area that were used by the Sudanese Armed Forces. And one of the most recent was Tolodi. And so Tolodi was what eventually became the capital of South Kordofan State. Before that, it was Kadugli. Even as we're analyzing South Kordofan State, Kadugli was primarily the capital, but Tolodi was soon becoming, and they were developing a lot. We were noticing a lot of development. And the information that guided us, what I was telling you about before, what my colleague created, was this. This was what we called the log. And what this was simply was a spreadsheet. And again, everything that we did was, by and large, very rudimentary, but it served a purpose. And so this was a collection of all ground reports from media, from UN situation reports, even from witness reports. And it was all collected in this log. It was all geocode. So I mean, you had the columns for latitude and longitude, and so anyone's had experience with this before, you can export these shape files and these CSV files from this document, and then you can upload it onto geospatial software. So you can upload it onto things like ArcGIS and ArcMap, and it would present points on the map of where you quantified the latitude and longitude. And this also worked for Google Earth as well, so you can export it as a KML file, K1 markup language, and load onto Google Earth, and all the points would be on there. So, in our database, we knew that Tolodi was the closest airstrip in that area, so that guided our scanning. So we were going to say, let's start looking that way. Let's go and scan towards Tolodi, keeping in mind that this is what is reported being in use, the Antonov AN-26. Transport plane, what they would do is, they didn't have weapons attached to the plane. It was largely, they would have Ukrainian pilots fly it because these were, traditionally Soviet machines. And they would have, usually Sudanese armed forces soldiers in the back of the Antonov with homemade barrel bombs. And so they would have, kind of oil drums and barrel bombs that they would, fill with explosive devices, and that's what they used for the harassment bombardment. And here's actually a ground photo, AN-26 actually. Yeah. And so AN-26 and AN-24, if you come across these, they're very similar, just slightly different engines. But anyway, so Tolodi, what we're noticing, at the same time, because we're observing Tolodi from November 2011 through January 2012. And Cauca Valley, this instance, was in January 2012 when we were trying to find evidence of harassment and bombardment. But one thing that we observed, in just 3 small images that we collected over that area, was that they were building their air capacity, right? They're enhancing an airstrip. They're building an airstrip. But not only were they building it, they were extending it. And so the airstrip started up 1,100 meters. Then in that close-up shot that I showed you here of the road graders and the excavators clearing out the earth is that they extended it by 200 more meters. And then finally they extended it by 1,800 meters. Now, 1,800 meters was significant to us because at that point we knew a lot about the Antonov because it was so often in use. But does anybody know why 1,800 meters was especially significant for us? Yeah. I mean that it now had the capacity to. Yeah. So now the Antonov could land. If it was any shorter, it would be kind of a disastrous endeavor. So I know Matthew was in Ida Camp. So if you've seen photos of Ida Camp, or if you've been there in what is now South Sudan, you'll see there's a crashed Antonov just because it had such a, they had a poor landing capacity at the time that didn't equip the landing. So that was enough for us. We're going to say, let's start looking at Tolodi. Let's start going in that direction. And so, we have our 2 sets of plumes here, kind of clear it out here for a second. And so we're starting from here and we're working that way because that's where Tolodi is. And so we're scanning slowly, and we're trying to register every bit of information that we can, looking at all the orchards, kind of going in that direction. And then finally, we come to this little guy here. And it's now AN-26. This first for us, like actually capturing this in the image, like the actual, the smoking gun, more or less. That's the reports that we're receiving. If you measure it out, in geospatial software, remote sensing software measures exactly to the dimensions of an AN-26, but I mean, you can also just visually, the photos I showed you earlier in the diagrams, the engines, the cockpit, the dimensions are just perfect. But what's also so striking about this is, look how low it is, right? I mean, this isn't just a simple travel that they're doing. This is pretty low. This structure here is about 18 meters. Here we have one that's probably 20, 25 meters. It's flying very low, and you can kind of see the ghosting effect, so it is moving. And so, boom, boom, boom. That was the reports that we were receiving. The method of attack, of harassment and indiscriminate bombardment, and then we were able to capture it. All right, I know we have a little less time to talk, so I'm going to go through this quickly. But this was the heart of what we analyzed during this time. And the reason why I'm talking so much about what we did during SSP is because that basically built up our analytic expertise and capacity. That was so unique at the time. Because at the time that I was doing this, the people that were doing this type of work in humanitarian space, you could count on one hand. It was me, it was Josh Lyons from Human Rights Watch, who will be talking Friday, and he's amazing. I've learned so much from him. So I'm really glad you guys will be able to hear him talk. And he was formerly of UNISAC, but also another capacity. UNISAC were also doing this as well. And they were actually part of our coalition when we first started. So Lars Brumley, a lot of you know, Einar Borbo. But once we started to analyze in the northern part of Sudan, in LOB, in that region, that was actually out of UN mandate, and so they had to withdraw from the project at the time. But I also learned a lot from Lars as well, in addition to the veterans in the analysis center. But in Kadugli, it is especially, we learned a lot from it, and it's something that for all of us that worked on the project at the time, we'll never forget. But in Kadugli, this was it wasn't a contested region, but it was a mixed population, basically, that were living here. And this is in South Kordofan. This was capital of South Kordofan state. But when I say mixed population, it was people that were northern aligned and southern aligned that were living in this town together. And they had for a long time. But once the fighting broke out, the governor, Harun, who was in control of Kadugli at that time, was northern aligned. And this is when you started to receive reports of indiscriminate, the intentional attacks on southern aligned people within Kadugli. And what we're receiving reports about were what was basically door-to-door killings. And the reports that we're receiving on the ground at the time was Sudanese armed forces and the police force were joined together, and they were using police trucks, Toyota Hiluxes, white Toyota pickup trucks, Land Cruisers, and driving door to door throughout Kadugli, conducting basically a kill spree throughout the town itself. And so we had to look at it. It was our obligation to look and to see what we could find. But at this time, this is in 2011, Kadugli, like I said before, it was unmapped. And so all these locations that we were receiving, all this information that we were receiving, we had no idea where to look. But we did have someone that survived. We had a witness that was able to escape. Him and his family were able to escape. And so an interlocutor, an intermediary who worked with the coalition, and he was able to interview the witness. And so he was giving us all the locations of things that we needed to look for, of where this violence was occurring, and who was involved in where this violence was originating from. And we had no idea where he was talking about. So we had to get this information. And they didn't have internet access where the interviews were being conducted. They didn't have Google Earth. They didn't have things where they could just drop a pinpoint and send it to us. So what we did is we got an image of Kadugli before it was time before the violence had occurred. So if he looked at the image and he looked inside of Kadugli and he said, "Oh yeah, that's where this happened. I can see it in the image." That wouldn't be the case because this was before the events of the attack. And so this was blank. when we sent it to him, it was set for the grid, but these red boxes, they were not on there. But we sent him a map of Kadugli, trying to get information on the area. And so that he could easily relay back to us what quadrants that we should look in and what we should analyze. So if he said to us, look in E4, that's the location you want to go to, something like that. But when we got the map back, not only did he give us the places that we need to look for, he gave us very specific information on all the structures in his town that he knew so well. And so we were able to get the police forces, we were able to get the hospitals. We got Governor Haroon's mansion. We got Sudanese Armed Forces 14th Division base. We got Norwegian Refugee Council, who were run out at the time. So during this time in Sudan, it was what was called non-permissive environment. So basically all NGOs, anybody was run out of Kadugli. And at this point now, we just had Sudanese Armed Forces along with the police force taking control. And so now we knew where the police station was. It was here. And this is what he relayed to us. And then when we started to observe, over time, was the buildup of the white Toyota pickup trucks. And so, they had typically machine guns fixed to the back of the Land Cruisers and the Hiluxes. But we're also noticing here, which we've never seen before, in all the imagery that we looked at Kadugli, did you see that? All the Toyota trucks parked out in front of people's houses. Consistent with the reports that we're receiving that they were going to people's houses, taking them out of their homes and killing them. In the same effect, the reason why we were trying to find out all this information was because we were receiving reports of the mass graves in Kadugli that were being dug at the time and being established. And through that, they set up what was called the kill box. And so you see here all these checkpoints. And this is on this compound, but this is way far north of Kadugli town itself. But that's where the airstrip is. Staff 14th Division, but here we have the town. But all these marked locations are where they set up the checkpoints. And this was basically to stop anyone from entering or exiting Kadugli. And you can kind of see in the close-ups that it's kind of hard to see here, but if you got closer to look, it's we have fighting positions here that I showed you earlier, foxholes around some tents. Actually, I believe there's armored vehicles in the shot, actually T-55 tanks. But very similar patterns, earthen berms dug around with tents set up on these checkpoints, and nobody was able to leave. And so we started to try to find the mass graves that were being reported. And through that, we had to keep sending maps back and forth so he could guide us to where we wanted to look. And this was the quadrant that he relayed back to us that we should check out. And then finally, through this very specific coordinates, he basically said that it was south of what is called the Tilo Boys School. And it was about a football field's length that he walked himself and remembered to the graves. And then we just followed that direction exactly from when he gave us the information on where the Tilo School is. And so this is the before shot, and then this is the after. And so here you see, also consistent with the reports that we're receiving, that they were using excavators and road graders to build these graves. And here, they dug 3 trenches and then would use the road grader to smooth the grave over. So that was the heart of what we did analyze at the time during SSB. It wasn't the only thing. We did about 28 reports when we were with them. And in 2012, we left. 2012, we left and we became a Signal program, still under Harbor Humanitarian Initiative, but it was largely with the focus of taking everything that we learned through SSP, because it was so rare at the time, so few people doing it, and teaching it. Teaching the methodology to other people. And that's a capacity that we serve now in the university. So we teach a course every year. And it's, by and large, the people that attend this course aren't analysts. but they come from all different backgrounds. They're from ICRC, there are people from IOM, there are people from MSF, there are people from the national laboratories in the US government, just seeing what can be used, what can be done, and see if it worked for them. But the technological capacity and information that we gathered from that time is something that still is the crux and the heart of the analysis that we do at the Signal Program. And so I'm gonna stray away, because of time's sake, from SSP and just talk a little about the technology that we observed at the time, why it was important to us. And so, Jamin and a couple other people were talking about the nadir angle in satellite imagery. And that's basically, if we have a 0 degree nadir angle, it's when the satellite is basically, the center is perpendicular to the surface. And so you see a shot like this in an urban environment of a building, and you just see the roofs. Right? You don't see the size of the building too well. But once you start to get a tilt in that sensor from the Earth's surface, you start to see a stretch here. And that's what they call distortion within the image, but you can actually see the sides of the building. So this is an Aleppo, and here we actually see the size of the building, which helps out a lot in an urban environment if you're trying to, if you're receiving reports of destruction that's occurring in buildings, which we have, because we started working in Syria after when we were in the Signal Program, and we found that by and large stuff with a higher degree of the air angle made navigating through urban environments a lot easier for us visually. But there's limitations to it. So in Cairo, some of you may remember this back in 2015, 2013. I don't know what it was. I don't know, yeah, it's sorry. So this was the St. Lebanon incident, but this was the bombing of Coptic Church in Cairo, Egypt. That we were receiving reports of at the time. And so we actually had an image over Cairo that was taken just a handful of, 2 or 3 hours after the attack occurred. And this was a devastating bombing in this church. Dozens were killed. And we were trying to find the location and the destruction of the reports that we were receiving of the church itself. Now, this image is taken of the church after that bombing happened, but what do you see? Nothing, right? It looks like a normal church. And this is the limitations of urban environments and structures that we were slowly experiencing, but didn't experience so much in Sudan and South Sudan just because the structures were different. The bombing happened inside the church. It was devastating. Bombing, a lot of damage. I think I have an internal shot here. But we couldn't see a thing. We couldn't see a thing even though the imagery was timed perfectly or normally we could. So I'm going to wrap that up here on Satellite Sentinel project and the origins of Signal and go into the work that we were doing with WFP. And so my colleague, Sarah Khan, is going to come up and talk a little bit about some of the key findings that we found when we're doing the work with WFP. And I have to say, just really quickly that the 8 years I've been doing this work, this has been the highlight for me, doing the work with WFP, the brilliant work that Sarah and Laura and Rashiri have been doing, meeting so many people like you that have been working with WFP that, just the past couple of days, I've already learned so much. Just because my background is different, for high resolution imagery analysis, but what you guys are doing is immensely valuable. And I've learned so much from it, and I've learned so much from working with Sarah and her team, and I'm just very thankful for it. So I will shut up now. I ramble, I know. So I'll let Sarah take it from here. Thank you.
Hello, we'll have time for questions. So I won't take much time. I just wanted to refocus a little bit again. So that was the history of SSP and the work that's been done there. And the more recent work that we've done, as Sarah had mentioned, was in collaboration with FAM here at WFP that started in 2016. And together, we've worked on quite a few different areas and type of analyses, and one of which was the use of very high resolution imagery in displacement, so things that Sarah had also talked about. So I won't repeat that, just focus on a particular case. Take 5 minutes in Dikwa, Nigeria, which is located in the northeastern portion of the country. And this case in particular was very interesting because the imagery from this time was actually used as evidence for the UN to issue a level 5 integrated food security phase classification. Sorry, it's a mouthful, so look at that. Which is a famine and human catastrophe that is classified as the highest level of emergency. It can then be used to provide more assistance and things. And this region, I'm sure many of you are aware, has been plagued by a lot of violence and conflict in the recent years. So the image that you actually see here was taken in, I believe, early July 2016. And what you see, this is the town of Dikwa up here, and this is actually a camp that was there. And these polygons represent some flooding that took place after excessive rainfall in the area. So there's this video, load it, see if it works. That will give you a bit of a progression of what that looks like. Okay, so as I mentioned, Dikwa is up in northeastern Nigeria in Borno State. And the town of Dikwa, this is it, and then the camp is located just down here. And this progression shows you how it has grown over time. Yes, between May 9th and June 23rd of 2016, again, due to the violence of the situation that has been ongoing. And so you can see with the delineated boundaries how it has been increasing over actually quite a short time period, about just over a month or so. And so through this progression, as the rains hit, there was a lot of rainfall and flooding in early July, and that really devastated parts of the camp. And so the image that showed earlier, you can see some of the flooding spread throughout the camp here as well. And so due to that flooding, it's an issue when it comes to cholera and sanitation and everything. The camp started clearing out. So September 16th, October 10th, you see that there's footprints left behind from this camp. But where do they go? They go to the town of Dikwa, which was just next door. And so then at the same time as the floods were happening, you can see that the new tents were being established throughout the region. And so you can see that in this series of progression. So July 30th was when we saw the imagery of the initial floods, and then you see small tents that were popping up around here in these areas, and it just continued. And so this video then shows a couple of more examples of how that started changing and establishing throughout the time. So it was a quite severe situation in this displacement. And you can see even the floodwaters in some of this imagery. So, just in terms of numbers, so again, this all happened in kind of the summer of 2016. And then what we saw after, again, was the establishment of all these camps throughout the town, which are actually quite clustering. If you're looking in these areas, these yellow dots represent the structures that were set up. So it's 1,400 in total, the majority of which were small informal settlements. But yeah, as you can see, they're quite spread out in this area. And then between beginning of December and end of February, you can see, the maps aren't entirely aligned, but you can see how much it's grown, and the total number of structures actually more than doubles. And this is true for the informal and the both formal settlements as well. So this is very similar to the things that we've heard about this week. It was just unique in the sense that this imagery we had, and you saw the progression of the flooding and the displacement from the camp and into the town of Dikwa. And this is actually also a case that is referred to in this workbook that was introduced yesterday by Sarah. So as a part of this project, one of the things that we've developed is a bit of an introductory guide to how to conduct remote sensing using very high resolution imagery to look at structures primarily. And so this is something that you'll be getting on a USB stick. I apologize, we don't have that for you yet. but we will. And it's a rather comprehensive yet bit of an overview document on kind of the steps of it's a review actually of what's already been talked about. So where to get your imagery from, the potential sources, and how to download that and import that into the software. And so and then how to analyze it, and then also produce the final products. And what is nice with that there's a bit of a step-by-step guidance on how to go through these steps. So you are, I think, a more advanced audience, but there is quite a bit of information also on how to look at individual structures and how to be able to identify those in terms of how to actually look at or look for a tuple versus a structure, and how can you tell in reference to the size and shape, and then also the limitations associated with some of that work. And so there's some videos and a lot of supplemental materials to kind of wrap all of that up. Yeah, so that's that, and you'll be getting that, and that's all for me. So thank you.
So this is manual, right? This is manual counting.
Yes.
Have you guys considered how much can you automate? Have you guys thought about this?
Yeah. I worked on it a little bit, actually, not as a part of Signal, outside of Signal, but it is something that many people are talking about. There's many ways of doing it, but it's still a very complicated process, just given these kinds of landscapes. So a lot of these processes have been tested on urban environments, rural environments, where structures are they look the same or they look different, and very levels of success. So even in yesterday's presentation, there was a demonstration of a product here, and what I've been noticing so far is that you still need a lot of human intervention in one way or another. And as I said, there's many ways of doing it. So this guide also has a bit of a portion on the different methods that have been tried and some of the literature that shows how it's been done. I still think that it's a little far from actually being implemented and used. From what I've been reading, at least, is that yes, there have been things that have proven to be successful, however you want to kind of quantify that. But I've also found that it's overly complicated, and I don't think that's necessarily transferable to the humanitarian community. So long, complicated equations or software that's not accessible and things like that. So I think that's a big gap that still needs to be bridged more. So like what WFP is working on is an amazing project. Once that it gets developed a little bit further along. So yes, and I'm trying it myself as well, but it's not nearly. So it still takes a lot of time and still takes a lot of human validation and things like that. But it's definitely on our minds. And your questions?
Is it possible to detect markets and not only the market itself, but also which are the markets, the projection of the market size, but also how many trucks are entering or something like that allows us to say if market is relevant or not?
Yeah, and markets are always the most notoriously, difficult for programming in automated. And they're very easily identifiable looking at visually because of how the structures are clustered together. So if you see the markets in like Soldery Camp, or in a lot of camps in Utah as well, you have the kind of tin roof structures kind of all clustered together. But when we've tried in the past to automate that, it's been notoriously difficult. I don't know if anyone's had experience with the success rate in identifying markets automatically, but yeah, here's one in Video Camp. Apollo. Yeah, so you can see all the structures clustered together around the roads, but yeah, it's always been one that's.
And area-based instead of structure count?
Oh, sorry.
Area-based.
Area-based?
Yeah, if you calculate, for instance, that you have so many people living per square meter, or it's counting areas instead of structures.
Yeah. I mean, there's been parts of that, but by and large, the capacity that we worked in was counting individual structures. And it was, mostly consistent structures that we're seeing that were, whether it was registered tents from UNHCR or OCHA or things like that, which are very distinct. So you have like the white and blue 3x3 meter tents, or then you have the UNHCR family style tents that are hexagon in shape. So those are very easy to pick out. But then you start to get into some areas like in Manguno, I remember in Borno State, where there's a lot more improvised structures. Something like a lean-to tent, which is kind of a tarp over a roadway, which is a lot harder to see the consistent pattern. But usually, it's in clusters where we best kind of phenomena. But yeah, I think in the case of Azaz and so in Syria, we weren't looking for a already established camp. That was in Azaz, but it was close to the Turkish border, and at that time, I believe it was they were expecting an incursion from ISIS in the town, and we started following the roads north of Azaz towards the Turkish border. We saw that they had the 3x3 meter UN tents set up in orchards alongside the road there, but it wasn't something that we were looking for initially. But it was something that we just started noticing itself. So yeah, looking for those consistent patterns. So let's keep an eye on.
Did I understand that correctly, that you wanted to not detect the market, but see how active that market is?
Yeah.
So you want to see if it's growing or shrinking or something
Yeah.
like that?
Yeah.
Manually, basically. No
Well,
matter how.
not
Yeah.
manually, but
I mean, just, yeah.
that's kind
Yeah.
of,
Have you done something like that, a time series of how big a market
Yeah,
is? or
yeah. Kind of similar to what you just saw with Dikwa, just the parameter of the camp itself expanding.
Yeah.
You can with the markets, because even though they're very clustered and they would appear haphazard, there's still a consistency there within the structures itself. So you can notice it. That's what we noticed in Zaire camp, was that the markets were expanding alongside the road, just because even though the individual structures themselves weren't comparatively the same, they were still conjoined, basically. And so yeah, you would notice that expansion alongside the road, and also kind of outwards into the tent area that surrounded the marketplace as well.
And then for automation, actually, I believe that markets are some of the hardest things to pick out, because they all look like one conjoined structure. So it's kind of the term that we use for multiple buildings or buildings that have shared roofs but are separate structures. The satellite won't be able to look at that, and even the human eye, it's very difficult to tell what exactly is the next stall or the next structure or something like that. So that will, I think, for a very long time.
And in some markets it's super difficult. Like I can show you pictures of the Rohingya camps, where what you're seeing is sort of a real estate natural dynamics, in which the people that moved next to the houses are now selling those structures for shopkeepers along the road, and so it's exactly the same structures that are just changing use. And you can see the dynamics happening as a normal real estate movement with the high value structures moving closer to the roads and along the roads, and people going sort of more into suburbs away from the streets.
Right.
I can show you pictures of what markets look. It's just exactly the same structure where people live in, like on the ground
Yeah,
level.
Yeah.
Oh, yes.
Quick thing, you mentioned about the Tukul detector, and I
Yes.
understand that that's a kind of automatically detecting a
Yes.
kind of a structured thing.
Yes.
How flexible it is to train it for another type of structure and in another area?
So I would assume pretty flexible. Like I said before, I didn't develop it. I supplied the data for it.
Sorry, just to add, but it's my understanding that it's trained on this conic,
Yes,
like
that's the
shape,
thing though.
right?
Yes,
So
it's-
then you can maybe introduce another training data set with a different structure? Is
that
what
would
you're
be
saying?
my
Okay.
that'd be my assumption.
Okay.
That'd be my assumption on doing that, because that's what we fed into it was very highly specific.
Mhm.
But there's metadata there within the imagery itself that you could supply. As far as my understanding was to the machine. So stuff like the sun position, sun azimuth, time of day, things like that. And typically the imagery that was captured over that we collected over Sudan at the time was you know, it is generally captured around the same time. So, let's say around tsunami time. And so the sun was, you know, very consistent in its position. But so yeah, so things like this, the shadow and the pitch shadow and the reflectance, I think were all things that he factored into it. In addition to the very consistent size and shape that we were noticing the patterns of. I mean, it was also, you know, disjoint tuples were also not just the same one, but they were also, the patterning was very, very significant.
And also, as you've seen, that tuples are a very specific structure, and if you start replicating that on a wider set of structures, the training data has to be much more than, you know, than just the tuples. They have to have different types of roofs and sizes and materials, and so that's something that, again, remains a challenge.
Can I just add something that might be useful for the rest of us? We've used this before, which is about the Corona satellite, the one that shoots film down to the Earth. The Corona satellite and the KVR, which is the Russian equivalent, are actually available for purchase, which can be quite interesting because you can have a before and after series from the 1960s. And so you can actually purchase submetric resolution images from the 1960s and compare it to now, mostly in Central Asia, I guess the KVR not necessarily, but and so it's a fascinating thing, so that you can have a before and after of a 60-year time series to compare things, and they're commercially available. So it might be interesting if you do have a very long time series that you want to do a before and after. That might be interesting to know.
Alright.
Did we keep in the time?
Yeah, I think we're still on schedule.
Minutes to spare.
Yeah.
Oh,
So
good.
another question